Hello everyone, my name is Brad. I'm with the Canada Masonry Design Center, and today I'm just making a quick video showing you how you can design a beam using mass. So when you open up the software and select new beam, this is what you will see. You'll see that there are three fields that are highlighted here. And so just to begin, I want to put in the dimensions of my beam. So I'm just going to put in 5 meters here for the sake of an example. For the height, I'm going to make it 3 courses. So I'll put in 590. And you'll see as soon as I put in the height and length, my dimensions show up here in the drawing window, and this is what my beam looks like. Also, once I have a beam that shows up, you'll see the next icon out of the 5 that show up here is highlighted, so I can now proceed to applying loads onto my beam. So now that I'm here, right now I have no loads, so I'll put an add load. And right now I'm just going to put a uniform dead load on my beam. So I'm going to put 3 kilonewtons per meter, and you can see as soon as I put it in here, it shows up as being applied on my beam. If I want to add another load, I'll do this. I just hit add load again. I'll make this a live load of 1 kilonewton per meter. And then I can also change the magnitude. So if I don't want it to be uniform, I can put in 0.5 here. I put 5 before. So it starts at 1 and then it ends having a magnitude of 0.5. You can also change where these are applied. So by default, whatever loads I apply will go all the way across my beam. But if I want it to start midway through, so 2.5 meters, I can change it to doing that way. And now if I wanted to have a load that tapers in the other direction, I can select this load, and when it's selected I can press copy, and you'll see I have 2 of the same loads. And so I'll change this second load to going from the beginning to 2.5 meters. It'll change the magnitudes to go from 0.5 to 1. And so you can see when I select all 3 of these, I got my original load of 3, and I've got these 2 separate loads applied on the beam. And then you can keep applying beams. You can put snow loads, all different types here. So you just choose the load that you're interested in applying and put in your magnitude, and then you are off and running. So I'm just going to put a 0.5 here, and I'll change it to being a snow load. And you'll see it once I have loads that are applied on my beam, the next button here, the moment deflection design stage, is highlighted. So when I click on this, now we're starting the actual design. And what the software does, it iterates through all of the possible block sizes and strengths, and same with reinforcement configurations to design for moment. And you can see here I have a successful design. If I specifically wanted to use a specific size and strength of unit, I can just deselect, and it'll redo my design. You can see how quickly it's going using the new parameters that I'm putting in. One common question I get with beams, you see this tied box here. If you have stirrups that are able to confine this top layer of steel here and keep it from buckling and compression, then you check that box, and then this steel is used as compression steel. By default, since at this point in the design, the software doesn't know whether or not we have the stirrups, it also doesn't know whether or not it can use that steel for compression. And that's why we have this checkbox here, making it a conscious decision by you if you're using the steel for compression. And so sometimes you'll get a failure design here saying that your steel is not yielding, which is a requirement for a masonry beam design in the S304. Simply by checking this box and using compression steel, it makes it a lot easier to raise that neutral axis and make sure that bottom layer of steel yields. So once you have a successful moment design, you'll see up here the shear design button is highlighted, so I can click on that, and then what happens, it'll quickly design for shear. And you can see it hasn't put stirrups in my beam. If I deselect the none option, it will put stirrups in my beam if I want them, but according to my design here, they were not necessary. And if I look at the shear diagram here, you can see the shear value that the beam was designed for and the shear strength of the masonry that I get. And so you can see that my beam is adequate without having that. I can also, with these drawings, look at the deflection, the actual bending moment experienced by the beam, the reaction forces, here are the loads once again, and the beam itself. And then also when we look at the results up here, you can see there's 2 layers of tabs. So there's a simplified and a detailed. These 2 tabs apply to the bottom row. So for example, we have the shear tab selected right now, and we're looking at the simplified results. If I click on detailed, it actually shows for all of the calculations that were used for shear, and you can see all of the references where all of the equations came from, what the equation actually was, and the result. So since there's no steel in this beam, for example, this VS value is 0, but this is where it would have been taken from. Same thing can be done for moments. If I go to simplified, if I look at deflection or for moment, these simplified results, they're meant to be a snapshot of the information that a designer is interested in looking at most of the time. But if you really want to dig into the nitty-gritty, you can click on detailed. It'll take a minute to load, and then every value that was used, you can see these and what the result was. And so if you want to go through, validate the software for yourself, you can easily go through and compare this with hand calculations. So once I have a successful shear design, you'll see the last stage, bearing design, is selected there, and you can simply put in the dimensions and information about your bearing plates. And if I go to simplified beam properties, I'll make this window a little bit bigger here so you can see all of it. This is where we have a summary of all of the different designs that have been done, and so now you can see what has been completed. And then if we had applied point loads to our beam, then it would have checked that as well. And so here you have it. This is the complete beam design. Thank you for watching our video, and I hope that you follow our channel on YouTube so you can see when we put new content up.